Imagine that your physical body shuts down entirely, and doctors offer a radical solution, a brand new host. Medical science calls this hypothetical procedure a brain transplant. But from a biological perspective, that label is backwards. You aren't getting a new brain, you're getting a new body. Every memory you hold, your distinct personality, and your entire sense of consciousness exist strictly within the folded gray tissue of your brain. If a surgeon successfully moves that tissue into another skull, the person waking up on the table hasn't changed. You would simply open your eyes, completely yourself, looking through the eyes of a stranger. Today, swapping human organs is a standardized practice. Surgeons routinely replace failing hearts, swap out kidneys, and transplant livers, treating these vital organs as interchangeable biological hardware. Yet moving the brain from one body to another remains an impenetrable biological wall. If medical science has mastered the ability to replace the physical engine of the human body, we have to ask why it is completely incapable of transferring the driver. The barrier has nothing to do with physical plumbing. A modern surgical team can easily stitch together the macrostructures of the neck, connecting skin, weaving muscle tissue, aligning vertebrae, and reattaching major blood vessels. The entire procedure collapses at a single, unavoidable intersection: the central nervous system. Your brain operates using billions of individual neurons, acting as a massive biological switchboard that fires constant signals down the spinal cord to operate your limbs and organs. Once a scalpel slices through that spinal cord, the microscopic pathways are violently severed. Modern medicine has no method to force millions of tiny, independent fibers to find their exact matching partners and resume communication. The math fails even if you attempt a partial transplant. Taking just a small section, like the cerebellum, and placing it into a new host requires mapping millions of overlapping connection points simultaneously, a task mathematically impossible for any surgeon to wire correctly. Flesh and bone are easy to sew. The true obstacle is the impossible engineering challenge of perfectly rewiring a microscopic superhighway. We know exactly what happens when brute force is applied against this biological limit, because 50 years ago, researchers actually tried it. In 1970, neurosurgeon Dr. Robert White spearheaded procedures where he transplanted the heads of live monkeys onto the bodies of others. The initial stages of the surgery worked. The connected blood vessels supplied oxygen, the transplanted brains remained electrically active, and the subjects woke up, able to track movement, chew, and swallow food. But the severed spinal cords remained completely dark. Unable to transmit a single command past the neck, the animals woke up paralyzed, entirely conscious but trapped inside unresponsive physical shells. The bodies quickly rejected the foreign tissue. None of the subjects survived the biological shock for more than 9 days. Dr. White's experiments provided a grim, conclusive piece of data. Severing the central nervous system doesn't create a medical cure. It isolates the consciousness. Modern researchers have entirely abandoned the idea of full-body swaps, choosing instead to focus on microscopic cellular repair. The current frontier of neurology relies on stem cells. Scientists are testing ways to inject these adaptable cells into damaged spinal tissue, hoping to coax them into organically bridging the broken gaps. Alongside stem cells, laboratories are successfully cultivating clusters of artificial brain tissue. The goal is no longer replacing a whole organ, but growing custom biological patches to repair localized neurological trauma. We cannot manually stitch a severed spinal cord back together. Instead, science is slowly figuring out how to prompt the nervous system to regrow its own lost pathways. Despite these steady advancements in cellular biology, transferring an entire human brain into a fresh host remains strictly confined to the realm of science fiction. But if future technology eventually provides a workaround for the spinal cord bottleneck, we are left to confront the psychological reality of the procedure. When your mind dictates the movement of unfamiliar hands and your consciousness processes the world through a stranger's biology, the lines of who you are begin to blur. So if human flesh eventually becomes just another piece of replaceable hardware, at what exact point does your true identity end? Let me know your take on this down in the comments.